In the vast universe of viruses, a new contender emerged. It appeared quietly in a bustling city in China. Wuhan, a hub of commerce and life, became the unexpected origin point of a global pandemic. This microscopic entity, SARS-CoV-2, caught the world off guard. It quickly revealed itself as a formidable opponent. The year was 2019. This is the story of COVID-19. Our story begins with a virus. Viruses are not alive in the traditional sense. They are packages of genetic material. They exist to replicate. To do this, they need a host. SARS-CoV-2 found its host in humans. This particular virus was new. Scientists had not encountered it before. This novelty made it more difficult to combat. Our immune systems had no pre-existing defenses. The early days of the outbreak were shrouded in uncertainty. Doctors in Wuhan began to see an unusual pattern of illness. Patients presented with respiratory symptoms. Fever, cough, and shortness of breath became the hallmarks of this new disease. The virus spread quickly. It moved silently from person to person. The world watched as the outbreak unfolded, unaware of the profound impact it would have on us all. SARS-CoV-2, the virus responsible for COVID-19, spreads with stealthy efficiency. Its primary mode of transmission is through respiratory droplets. When an infected person coughs, sneezes, or even talks, tiny droplets of saliva and mucus laden with the virus are launched into the air. These droplets can travel up to 6 feet. They can linger in the air for minutes to hours. Inhalation of these infected droplets by a healthy individual allows the virus to enter the respiratory system. Once inside, it begins its mission to replicate. While airborne transmission is the primary route, the virus can also spread through contact with contaminated surfaces. Droplets can land on objects. These objects become potential vectors for transmission. Touching a contaminated surface and then touching your face, particularly your eyes, nose, or mouth, can introduce the virus into your system. The virus's ability to survive on surfaces varies depending on the material and environmental conditions. However, it is always best to err on the side of caution. Frequent hand washing and surface disinfection are crucial in preventing the spread of the virus. These simple measures, often overlooked, are our first line of defense in this microscopic battle. The SARS-CoV-2 virus, like a microscopic invader, targets specific cells within our body. Its primary target is the epithelial cells that line our respiratory system. These cells are the gateway to our lungs. They are responsible for oxygen exchange. The virus is equipped with spike proteins which protrude from its surface, giving it a crown-like appearance. These spikes act as keys, searching for the right lock on the surface of our cells. The lock in this case is the ACE2 receptor, a protein found on the surface of many cells, including those in the lungs. When the virus's spike protein binds to the ACE2 receptor, it triggers a series of events that allow the virus to enter the cell. Think of it as a Trojan horse strategy. Once inside, the virus hijacks the cell's machinery, transforming it into a virus-producing factory. The virus releases its RNA, its genetic blueprint, into the cell. The cell, following the instructions encoded in the RNA, begins to produce more virus particles. These new viruses then assemble themselves within the infected cell. Eventually, the cell, overwhelmed by the sheer number of virus particles, bursts open. This releases the newly formed viruses to infect neighboring cells. The cycle of infection and replication continues. Section 4. The body fights back immune response and complications. Our immune system is a complex network of cells and processes designed to protect us from invaders. When a foreign entity, like the SARS-CoV-2 virus, enters our body, the immune system launches a multi-pronged attack. The first line of defense is the innate immune response. This is a non-specific response that targets any pathogen. Think of it as the body's rapid response team. Cells like macrophages and neutrophils identify and engulf the virus, while natural killer cells release chemicals to destroy infected cells. This initial response is often enough to control the infection. However, in some cases, the virus can evade the innate immune system. This triggers the adaptive immune response, a more targeted and powerful defense mechanism. The adaptive immune system relies on T cells and B cells. T cells recognize and destroy infected cells, while B cells produce antibodies that bind to the virus, neutralizing it and preventing it from infecting other cells. This targeted response takes time to develop but provides long-lasting immunity. However, in some individuals, the immune response to SARS-CoV-2 can become dysregulated, leading to an overreaction known as a cytokine storm. Section 5. A global threat, severity and mortality of COVID-19. The severity of COVID-19 varies widely. Some individuals experience mild symptoms, resembling a common cold. Others develop more severe illness, including pneumonia, which affects the lungs' ability to exchange oxygen. In severe cases, the infection can lead to acute respiratory distress syndrome, or ARDS, a life-threatening condition where the lungs can no longer provide enough oxygen to the body. The mortality rate of COVID-19 is higher than that of the flu, but lower than diseases like SARS and MERS. However, it's important to note that mortality rates can vary depending on several factors, including age, underlying health conditions, and access to healthcare. The elderly and those with pre-existing medical conditions are at higher risk of developing severe illness and complications from COVID-19. The virus's rapid spread and the potential for severe illness make it a significant public health threat. Unlike seasonal flu, which we have some immunity to due to previous exposure and vaccinations, COVID-19 is a novel virus. This means our immune systems have not encountered it before, making us more susceptible to infection. Section 6. Healthcare under siege, the pandemic's impact. The COVID-19 pandemic has placed an unprecedented strain on healthcare systems worldwide. The rapid surge in cases, particularly during the early days of the outbreak, overwhelmed hospitals and healthcare workers. Intensive care units reached capacity. Ventilators, essential for supporting patients with severe respiratory distress, were in short supply. The pandemic exposed vulnerabilities in healthcare infrastructure and highlighted the critical role of public health measures in preventing system collapse. The shortage of personal protective equipment, or PPE, put healthcare workers at risk, further exacerbating the crisis. The pandemic also disrupted routine medical care. Elective surgeries were postponed. People were hesitant to seek medical attention for fear of contracting the virus. The pandemic's impact extended beyond the immediate healthcare crisis. The economic fallout, social isolation, and mental health toll have had far-reaching consequences. The pandemic has forced us to rethink how we deliver healthcare, manage public health emergencies, and prepare for future threats. Section 7. Our collective shield, measures for control and protection. Controlling SARS-CoV-2 requires a multifaceted approach. Individual actions and public health measures form a collective shield. Hand hygiene is crucial. Wash hands for at least 20 seconds. Maintain 6 feet distance. Wear masks to reduce droplet spread. Masks add protection. Quarantine and isolation break transmission. Quarantine separates exposed individuals. Isolation is for positive cases. These measures prevent spread. Vaccines curb the pandemic. Vaccines trigger immune response. Prepares immune system. Vaccination and preventive measures control the pandemic.